if u is equal to x cube minus 3x into y square plus x plus e power x into cos y plus 1, show that del square u by del x square plus del square u by del y square is equal to 0. Here they have given the function. We have to show that first order and second order derivative, after finding first order and second order derivative, we have to show that del square u by del x square plus del square u by del y square value equal to 0. Consider the given function. Call this as equation number 1. First we have to find del u by del x and del u by del y. Then we have to find del square u by del x square and del square u by del y square. First differentiate equation 1 partially with respect to x. We get del u by del x as del by del x of, here u is this, x cube minus 3xy square plus x plus e power x into cos y plus 1. Here we have to differentiate partially with respect to x, means y, we have to consider y as constant. Hence here differentiation of x cube is 3x square minus here 3 into y square constant take as it is into differentiation of x is 1 plus here differentiation of x is 1 plus here cos y is constant take as it is into differentiation of e power x is again e power x plus here differentiation of 1 is 0. So no need to take that equation. So no need to take that value. Hence we get del u by del x value as this. Next step we have to find del square u by del x square, that is partially we have to differentiate this equation. We get del by del x of, here del u by del x value is 3x square minus 3y square plus 1 plus e power x into cos y. Here differentiation of 3x square is 6x. Here this is constant term, so differentiation of constant is 0. Here also 0 plus here cos y is constant take as it is into differentiation of e power x is again e power x. Hence this is del square u by del x square value, that is 6x plus e power x into cos y. Similarly we have to find del u by del y and del square u by del y square. For that differentiate equation 1 partially with respect to y. We get, here we have to differentiate this term partially with respect to y. We get del u by del y as del by del y of the function u. Hence you have to differentiate partially with respect to y, means you have to consider x as constant. So dear, here this is constant term, so differentiation of constant is 0. Here minus 3x is constant take as it is into, here differentiation of y square is 2y. Hence we get 3 into 2 is 6. Hence we get minus 6xy. Here this is constant, so differentiation of constant is 0 plus here e power x is constant take as it is into differentiation of cos y is minus sin y. Hence you get minus e power x into sin y plus here differentiation of constant is 0. This is our del u by del y value. Similarly we have to differentiate this term partially with respect to y. We get del square u by del y square as del by del y of del u by del y. We know that del u by del y value is minus 6xy minus e power x into sin y. You have to differentiate this term partially with respect to y, means consider x as constant. Hence we get here minus 6x is constant take as it is into differentiation of y is 1. Hence we get minus 6x minus here e power x is constant take as it is into differentiation of sin y is cos y. Hence we get minus e power x into cos. This is del square u by del y square. After finding del square u by del x square and del square u by del y square, you have to consider this LHS of the equation, that is del square u by del x square plus del square u by del y square, which is equal to, here del square u by del x square is 6x plus e power x into cos y plus del square u by del y square is minus 6x minus e power x into cos y. After substituting all the values, here plus 6x and minus 6x gets cancelled, plus e power x into cos y minus e power x into cos y gets cancelled. Hence we get the value of del square u by del x square plus del square u by del y square value as 0. This completes the problem.